So guys, today we're going to talk about norm spaces and see certain examples of it. Now, what do I mean by norm space? By norm space, I mean a vector space with a norm defined on it. A vector space with a norm. And what is this norm? This norm is a real valued function on X. You can also think of a norm as this notion of a length of a vector. For example, if I have an element small x belonging to my vector space capital X, by norm of this element I mean a function which takes this element to a non-negative real number, and these are the four properties that this norm function should satisfy. Let's look at them one by one. So the norm of any element in the vector space X has to be greater than or equal to 0. The second property is if the norm of any element X is 0, if and only if the element itself is 0. That's pretty much simple too. Let's move on to the third property, and that is if you do scalar multiplication, then it's simply norm of scalar alpha times norm of X. So norm of alpha X is equals to norm of alpha times norm of X. And the fourth property is the norm of X plus Y is less than or equal to norm of X plus norm of Y. So this is essentially what a norm space is. And if you look at certain examples of it, the foremost example is our space Rn. And now Rn, I mean that a space in which every point is a vector with n dimensions. So I can write it as x1 till xn, where x is equal to x1 to xn. So if x is a point in Rn, it can be represented like this, and the norm of any element in my space Rn is given by this formula. Yeah, that's pretty much it for norm spaces. See you in the next video.